Hello students, welcome to the next lecture on the multivariate normal distribution. Today I will explain you the various examples related to the conditional distribution. Myself Dr. Harish Garg. You can follow my YouTube channel where you can find the playlist of the applied multivariate analysis, and you can see the various lectures related to the bivariate normal distribution, multivariate, transformations, independent marginal density function, conditional density functions, all are available in this playlist. You can subscribe my YouTube channel so that you can get the notification in advance. So what we have discussed in our last lecture, we have defined the conditional density function, or called as the conditional distribution, which is defined by this manner: x1 condition x2, which is again a multivariate normal distribution with the mean is my mu and covariance matrix is denoted by sigma, and the formula that we have derived in this lecture is given by this number. Now you can easily remember this formula, that is a I with condition j. Fine, this is the rule for that. Then the mean will be the first quantity, that is I, that is the mean of I, plus the covariance between them, covariance divided by variance of this. What is the variance of this? Sigma jj, because this is a vector quantity, so instead of the division it's an inverse into condition of this, that is xj minus mean of this quantity. This is the way you can remember this expression. Otherwise you can recall this lecture where I have used the trick how you can recall this formula. Similarly, the covariance matrix is defined as this number. Remember, some books and some notation have defined this notation to be II dot j. Either you can use this notation or you can use this notation, you will get the same term. Now remember that I will always use this expression to define this illustrative example. What are the tips before I start with the illustrative example? Your step number 1 is always to find x1 and x2. Fine, your target is to find the x1 and x2. Then step number 2 is define the mu and define sigma corresponding to step number 1. And the last step is you have to apply the formula for mu 1 condition 2 and sigma 1 condition 2. Remember, you have to remember only this formula. There is no need to, if somebody will ask you find x1 condition x3, still you can use this formula. If somebody will ask you find x2 condition x4, still you can use this formula. How? We will see in this example. Firstly, step 1 is you have to identify what is x1, what is x2. Fine. Now look at that. Your target is to find the conditional distribution of x1, x2 given x3. This is my required target. Now you can compare this with x1 condition x2, x1 condition x2. Can you find the value of x1? X1 will be x1 x2 and x2 will be x3. Fine, this is your target. I hope it is clear up to this point. Now fine, x1 will be here, x2 will be x. Now step number 2, you have to define these numbers. So you have to write this is x1, that is x1, x2, and then you can define the x3. Similarly for here, x1, x2, x3. Again it is x1, x2 and x3. If for example your x1 will be say x1, x3 and your x2 will be say x2, then what will be your, this one is x1, x3, x2, x1, x3, x2, which is in the second part. Then you have to complete this matrix from here. What is the x1, x1? This number is my x1, x2, x3. This is my x1, x2, x3. x1, x1 is 1.0. x1, x2 is 0.8 and so on. You can complete this matrix. Similarly, what is the mean is What is the mu is given to be 0, 0, 0. So this number x1 is 0, x2 0, x3 0. So this is my step number 2. Then we always define x1 condition x2 by this method, where mu1 2 and mu are this number. Now you can see this is my x1, this is my x2, this is my x3, this is my x1, this is my x2, this is my x3. Now x1 and x2 are the one numbers, so I can take x1 and x2 are my one number. Fine. So that is basically I can do the partition. I can substitute this value, this point. What is the mu1? This is mu1. Mu1 is 2 number. So this is 0, 0. What is the mu1 is? X1. This is my mu1. Plus sigma 1, 2. This complete number is my x1. This complete number is my x1. This is my x2. So 1, 2 minus 0.4. Sigma 1, 2, this number. What is the inverse of the 1 is? Still 1. What is x2? This is my x3. Minus mu2 is 0. Fine. So from this, always remember you are not using this matrix. Always use this matrix. Now you can substitute this value x1, 2. This is my x1. Fine. This is my x2. Fine. This is my x2. X1, x2. This complete number. Now you can open this bracket. 0 will be 0. This is again x3. So if you multiply them, it is 0.4 and minus 0.56. X3 is the mean of this number. Now you can substitute this value here. What is the sigma 1, 1? This is my x1. Fine. So this number is my here 1.0, 0.8, 0.8, 1.0 minus. What is sigma 1, 2? This is my x1. This is my x2. X1, x2 will be my minus 0.4 minus 0.56. Sigma 2, 2, only 1. 1 inverse will be 1. Sigma 2, 1. Sigma 2, 1 will be this number. 2 and 1. Minus 0.4 minus 0.56. Now you can multiply them. It is 1.8, 0.8, 0.8, this number. Now if you multiply them, it is 0.4 minus 0.56. When you multiply with 1, it comes to be this same number. Now it's a 2 matrix. Now you can multiply them. It's a minus 0.16. You can multiply this minus minus plus 0.4 into 0.56. This is 0.4 minus, it is negative. So minus minus plus is a minus minus plus. It is minus minus plus 0.56 and it is minus minus plus 0.6. Fine. Now you have the 2 matrix. Now you can subtract them. You will get the 1 minus 0.6. It will be 0.84. 0.8 minus this, you will get this number. Hence, x1 condition x2 is also the multivariate normal distribution with the 2 having dimension. Why it is a 2? Because what is the dimension of the x1? It involves the 2 elements, so its dimension is 2. Now look at this second part. For this second part, can you identify x1? Can you identify x2? How you write this condition? Your target is to write this given x2. So that means x1 will be my x1, x3 and x2 will be my this. So what is my sigma? This will be x1, x3, x2, x1, x3, x2. Now can you complete this value? x1 is 1, x1, x3 minus 0.4, x1, x2 0.8, x3, x1 minus 0.4, x3, 1, x3, x2 0.6, x2, x1 0.8 minus 0.6, x2 is 1.0. Now once you can complete this sigma, again what is the mu? Mu will be x1, x3, x2, because it's a 0, x1 is 0, x2 is 0, x3 is 0. Now what is the dimension of this is? What is the dimension of this matrix? 2. So your matrix is again normal distribution, this number. So we can again use the same formula. What is the mu1? Remember, this number is my mu1. Fine. And this is my mu2. Now what is the mu1? That is a mean. So it has a 2 dimension, 0. Sigma 1, 2. This number 0.8 minus 0.56. Fine. This is x1. This is my x2. Sigma 2, 2 inverse. That is a 1.0 inverse. x2 is my x2. What is the mean of this second? 0. Now you can multiply them. It's a 0. It's a 1 inverse is 1. 0.8 minus 0.56. x2 is the right answer of this problem. What is the sigma 1, 1? This is my sigma 1, 1 because it has a x1 and x3. 1.0 minus 0.4 minus 0.4, 1.0. What is the sigma 1, 2? 0.8, 0.56. Sigma 2, 2 inverse, that's a 1 inverse is 1, and sigma 2, 1 is this number. Always remember, this is the transpose of this. Sigma 2, 1 is always sigma 1, 2 transpose. Now you can multiply these two numbers. You will get as a 4 cross 4 matrix, and this number is already a 4 cross 4 matrix. So once you can multiply them and subtract it, you can subtract them. The first number will be 0.36, 1 minus 0.6, 0.4 plus it will be 0.048 is the required answer of this problem. Look at the third case. For this case, can you compare them again? You can see what is my x1 and x2 for the third case. Your target is to define x2, x3, condition x1. So this number will be my x2, x3, x2 will be my x1. So can you define the sigma? This matrix will be, first number is x2, x3, then x1. Same for here, x2, x3, x1. What is the value of the x2, x2 from this matrix? 1. x2, x3, this is my x2, x3 minus 0.56. x2, x1, 0.8, and you can see the first row appears. Similarly, you can find the second row, you will get this and. Similarly, what is the mu? It will be my x2, x3, x1, because here matrix is always 0, 0, 0, so this the value are similar. Now what is the dimension of this? Dimension is my 2, so again it's a multivariate normal distribution with the size 2. Again we can use the same formula. So in that case, this will be my 1, this is my 2. So mu1, that is a mean having the dimension 2, sigma 1, 2, 0.8 minus 0.4. Sigma 2, 2 is 1 inverse. x2, that is my x1, mu2 is my 0. Now you can multiply them, you will get this is the right answer. Similarly, for this case, this is my sigma 1, 1. Sigma 1, 2 is my this number, and this is my transpose of this quantity. You can multiply them, it's a 2 cross 2, again you can subtract them, you will get this is the right answer. If x1 and x2 are jointly distributed with normals xi's, mean 0, variance 1. If the distribution of x2 given x1 will follow normal distribution 0, 1 minus here, then find the covariance matrix of x1, x2. This is given to you, fine, and this is your required target. So what is the dimension of this? Because it has only the two dimension, so this will be my 2 cross 2, that is sigma 1, 1, sigma 1, 2, sigma 2, 1, sigma 2, 2, and your target is to find these 4 numbers. It's a very simple. What is given to you? Mean are my zeros, variances of xi's are my 1, so the diagonals are 1. So it means your target is to find only these numbers. Fine. Also, we all know it is a positive symmetric matrix, so this is always same, so it means I need to find only one value. What is given to you? This is given to you. Fine. What does it means? 2 condition 1, this comes to be 0. Fine. And 2 condition 1 is my 1 minus rho square. It is given to you. Fine. Now you can compare them. It comes to be this number, because this part is given to you 0. So I can substitute this number. It comes to be 1 minus rho square. What is this number? Is 1 from this matrix. This number we don't know. This is my 1 inverse. This is my here. Fine. Now 1 will be cancelled out. Minus and minus will be cancelled out. So, and both are always same. So it is sigma 1 2 square is rho square. So can you find the value of this? It is my rho. Fine. So if I substitute this value, what is your positive symmetric matrix is the right answer. Okay, look at this another one. Again, your target is to find the conditional distribution of x2 given that x1 and x3. This is your required target. What is your x1? What is your x2? This will be my x2. This will be my x1 comma x3. Fine. So it means I have to write x1 is my x2 and x2 is my x1 comma x3. So what is my sigma matrix? So x1, that is this, x1 x3, x2 x1 x3. So what is the x2 and x2 from this? That is 5. x2 x1 x, remember that this is x1, this is x2, this is x3, same for here. So then this number is my 0. x2 x1 x1 x2 minus of 2, x1 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 x3, x3 x2 0 0 and 2. So this matrix will be my 5 minus 2 0 minus 2 1 0 0 0 2. Can you define the mu? Mu will be my x2 x1 x3. What is the mean of these 2? 1. Mean of the 1 is this, and so this number will be my this part. Fine. Now what is the dimension of this? 1. So it means x1 condition x2 follows n1. n1 is my standard normal distribution. So this and part of this, where mu1 and what is the value of the mu1? This is my mu1, only first part. Remember, now this is my x2, this is my x1. Fine. What is the 1 2? That is these two numbers, minus 2 0. What is the sigma 2 2? Now remember, sigma 2 2 will be my 1 0 0 2. So what is that? And can you find the inverse? It is my 2. So therefore, now since it is a diagonal entries, fine. So once it's a diagonal entry, you can reciprocal of its elements. That is my inverse. I can substitute here 0 1 0 0 half. What is x2? x2 is my x1 x3, x1 x3 minus mu. What is the mean of the second component? Is minus 3 4. So this part will be x1 plus 3 x3 minus 4. Fine. Now you can multiply them. It will be minus 2 0. Now I can multiply them. It is x1 plus 3 and it is 0.5 x3 minus 2. Now again you can multiply them. It will be 1 minus 2x1 minus 6 plus 0 minus 0. So that comes to be minus 2x1 plus 5 is the right answer. Plus 5. No. it is minus 2, minus 6, and it's minus 5. So your answer is x2, x1 minus 5. Similarly, you can substitute here. What is the sigma 1, 1? 5. Sigma 1, 2. This is my sigma 1, 2. Sigma 2 inverse. I already compute that 0, half. And this number is always a transpose of this part. Now can you multiply them? It's very easy. Now you can multiply them. It's minus 2, 0. It will be minus 2 plus 0. It is 0 plus 0. Now you can multiply this. It's a 4, 0. So 5 minus 4 is 1. So therefore this component will be, it's a minus minus plus, it's a 5 minus minus plus 5 minus 4 is 1. So therefore this will follow the normal distribution with the mean minus 2x1 minus 5 and variance is 1 is the right answer. Okay, again it's a conditional distribution. Your required targets to find firstly this. Find the conditional distribution of x3 condition x1 comma x2. So what is my x1 is? This is my x1. This is my x2. Fine. Then your target is to complete this variance matrix. So this is my x3. This is x1, x2, x3, x1, x2. x3, x3 is 2, x3, x1, 1, 2. So the first line is 2, 1, 2. x1, x3. This is x1, this is x3, 1. x1, 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 1, 1, 1. x2, x3, x2, x1, x2, x2. So this is my matrix. What is the mu? Again with the same notation, this is x3, x1, x1, x2. What is x3? 1. x1, 2. Then minus 3. So 1, 2, minus 3 is the matrix. Fine. So remember, what is the dimension of this? 1. So you can say it's a normal distribution. This one. This is my x1. Fine. This is my sigma 2, 2. This number is, what is this number is now? Sigma 1, 2. This is sigma 2, 1. Now I can apply this formula again. What is a mu 1? Mu 1 means x3, that is only one number. 1, 2. This is my 1, 2. Sigma 2, 2. So 1, 1, 1, 3. This is my sigma 2, 2. What is the determinant of this? It is 3 minus 1, 2. So can you find the inverse of this matrix? Sigma 2, 2 will be 3 by 2, minus 1 over 2, minus 1 over 2, 1 over 2. So I can substitute here into, what is x2? x2 will be my this number. So x1, x2 minus, what is the mean of this x1, x2? 2 and minus 3. So what is the value of this? It is x1 minus 2, x2 plus 3. So I can substitute this inverse at this point. Now you can open this bracket. It is 1, 2. So if I multiply them, it is 1.5 x1 minus 3 minus 0.5 x2 minus 1.5. Similarly from here, minus 0.5 x1 plus 1 plus 0.5 x2 plus 1.5. Or you can say it's a minus 4.5 and it is 2.5. Now I can open this bracket. I can multiply first quantity by x1. This is 0.5 x2. It's just a simple matrix multiplication. Plus twice of this, plus twice of this, plus twice of this. So what is the expression of this? x1, x1, 0.5 x1, x2, x2 plus 0.5 x2 constant number 0.5, 1.5. So I can substitute 1.5. Now what is the sigma 1 1? Because it has only one element, that's a 2, sigma 1 2, 1 comma 2. What is the inverse of this? I have computed this inverse, 3 by 2, 1 by 2 and this number. Now you can multiply them. It is 1 into 2. It is 3 by 2 minus 2 by 2, half. It is minus 1 by 2 plus 2 by 2, again half. Now you can multiply them. It will be 2 minus half plus 1. So it's a 3 by 2. That comes to be 2 minus 3 by 2. That is 1 over 2 is the right answer. So I can substitute here. It follows the normal distribution with the mean this quantity, variance 1 by 2. Okay, look at this another number. Find the conditional distribution x1, x2. Fine. Your required target is to find the conditional distribution of this condition. X2 is my 5. So definitely this number will be my here, and this number will be x1 plus 3x3. Now this is slightly different question. Now it means your first target is to find the covariance matrix and the mean of this number. Fine. Or you can say, if I taken this number as a y1, fine. If I taken this number as a y1 and this as a say y2, then what is your required target? So your required target is to find the value of y1, condition y2. That means your x1 will be your y1, x1 will be your y1 and x2 will be your y2. So for that I need to find the mean of y1 and y2 and covariance matrix of y1 and y2. So how you can find the covariance matrix? There are the two methods, as I told you in the previous lecture. One is the transformation method and second is the covariance method. So I will explain you both firstly. So we need the covariance matrix. The first method, by using the covariance. What is the mean of this? What is the y1 is here? What is that? It is expected value of x1 plus 3 times expected value of x2, and this number is off here. What is the expected value of x1 is 2. Expected value of x2 is minus 1. So this part is so it is minus 1, minus 1. So the mean of the y is minus, it is x1, x3. Sorry, it's x1, x3. So x3 has plus 1. So it is 5 and minus 1. Then your target is to find the covariance of y, that is y1, y2, y1, y2. So this is my target. So firstly find the variance of y1. Variance of y1 is x1 plus 3x3. How you can solve that? Variance of x1 plus 9, 3 square is 9, plus 3 to the 6, covariance of x1, x3. Find twice of this. What is the covariance of x1, x3 is? Because this is the covariance matrix of x. Fine. So this number will be my 0. Variance of x1 is 5. Variance of x3 is 9. This number is 0. So that is 86. So this number is my 86. Fine. Now I can find the variance of y2. What is the y2 is? x2. So what is the variance of x2? That is my 4. Fine. Now I need to find these two numbers because they are symmetrics. I need to find only one part, y1, y2. What is the y1 is? This number. Fine. Now you can open the covariance property, x1 comma x2 plus 3 outside, covariance x3 x2. What is the covariance x1 x2? Minus 2. 3 into covariance of x3 x2 0. Fine. So the answer is minus 2 is the right answer. Now once you know the covariance matrix, this is the first method to find the covariance matrix. Second method is you can apply the transformation. What is the transformation of this? You can see y1 y2, which is I can write in terms of the matrix. For the first line, this x is x1 x2 x3. What is the coefficient of x1? 1. Coefficient of x2? 0. Coefficient of x3 is 3. y2, coefficient of x1? 0, 1, 0. So therefore this C is my this matrix. Now the rank is my less than of the number of the columns. So therefore Y will follows again the normal distribution, but with the dimension 2, having the mean this C sigma C transpose. Fine. So now you can find the C into C. So what is the 1 0 0 1 3 0? What is the mu? Mu is my this number 2 minus 1 1. So can you multiply them? 2 plus 0 plus 3, 0 minus 1 plus 0. So that comes to be 5 and minus 1, which is similar to the previous method. Again, for this case 1 0 0 1 3 0, sigma will be my this number and the transpose will be here. Fine. Now once you can multiply this matrix, you will get the same matrix as we have obtained previously. So therefore now since this is my target, fine, now I have to write these two matrices, and again I have used the same formula. So this is a y1 and y2. This is my y1, this is my y2. So what is the mu1? 5. What is the sigma 1 2? This is my sigma 1 2. Sigma 2 2 inverse 4 inverse. y2, what is the y2 is x2, and x2 value is given to be 5. If it is not given, then you can write as x2, but it is given that is a 5, so I can substitute 5. Mean, remember that this is all for y. This is not for this, not for this. This is for this matrix. What is the mu2? Minus 1. So minus minus plus 1. Now you can solve this. It's a minus 2 upon 4 into 6. Now you can solve that. It's a 12 by 3, 4, 3. So 5 minus 3 is 2 is the 6 to the 12 divided by 4. So 3, 5 minus 3 is 2 is the right answer. Sigma 1 1, 86. Sigma 1 2, minus of 2. Inverse of this is 1 over 4. Sigma 2 1 minus 2. So that comes to be 86 plus 4 is cancel out 1. So that is 85. So therefore this follows my normal distribution with the mean 2, variance 85. That is the right answer of this problem. So I hope you can like my video as well. We will see the next lecture on the moment generating functions of the multivariate distribution. Till then, you can like, share and comment on video. Best of luck students. Happy learning.